targets the gene, and RNAi targets the messenger RNA. What if you want to target the pre-messenger RNA? Then you can turn to antisense oligonucleotides, or ASOs. ASOs are short pieces of chemically modified nucleic acids that can bind to either the pre-mRNA to influence splicing, or they can bind to the messenger RNA to influence translation, as well as to promote degradation of those messenger RNAs. You might be wondering, why might you want to target the splicing? Well, certain diseases are actually caused by defects in the splicing, and even when they're not caused by defects in the splicing, sometimes you kind of have backup copies of a gene that can be activated by activating the splicing of those genes in the proper way. A great example of this is Spinraza or nusinersen, which basically allows cells to use a backup copy of the SMN gene in order to supplement the defective SMN gene in patients with spinal muscular atrophy. The way that this works is by basically hiding a site that normally binds to a suppressor of the splicing, thereby blocking the suppressor from binding and allowing the full-length SMN2 to be made. You can also have these ASOs that bind to the messenger RNA, similarly to with RNA interference or RNAi. The difference here is that RNAi uses a short RNA, such as an siRNA, that binds to the protein argonaute, and then argonaute binds to the site of interest through the RNA interface. In the case of ASOs, the ASO binds by itself directly to your target, and then the enzyme RNase H recognizes that there's an RNA-DNA duplex, and it cuts the strand of the RNA, degrading the messenger RNA. And if by binding it can block translation, these nucleic acids are often chemically modified in order to make them more stable, but it also is going to make it harder for RNase H to recognize. So we actually sometimes do gapmers. The gapmers, they have a kind of window where it has just normal DNA, and then on the sides it's got the chemically modified DNA that's going to protect the ends. It's going to increase the affinity, the strength of the binding to the site. It's going to increase the stability of these compounds. And so you might see this term gapmer, where you have this normal DNA and then it's kind of capped by the modified nucleic acids. Scientists, what they'll often do is an ASO walk. They'll make overlapping ASOs and they'll test them one at a time to see which one works best. There you go, ASOs. Got an oligo, a short nucleotide sequence that is going to bind to the sense strand. So the chemically modified nucleic acids, they can bind to the pre-mRNA, influence splicing, or they can bind to the messenger RNA, influence translation, and also cause the degradation of those messenger RNAs through the actions of RNase H